Good evening. Here in this class of physics, I am going to show you theoretical proof of Pascal's law. In hydrostatics, in your earlier classes, you have studied Pascal's law, statement of the Pascal's law. The pressure at a point in a fluid at rest is same in all directions. So this is the statement of Pascal's law. Okay. And in this class, I am now going to show you the theoretical proof. The theoretical proof of Pascal's law can be done two ways. One, by taking two-dimensional fluid element, and another one is by taking three-dimensional fluid element. But I think three-dimensional proof will be difficult for you to understand at this present moment. So it's better if you first study two-dimensional proof, and then I'll go for you. I'll make another video for three-dimensional proof. So for two-dimensional proof, you take what? Two axes, x-axis and the z-axis, y-axis. So you know that x-axis will be the horizontal one. Okay. Normally this is the convention. X-axis is the horizontal one and perpendicular to this is the y-axis. Okay. And this is the origin O, where both axes meet. That is the origin. Okay. Now you join by a straight line like this. Okay. Say this point is denoted by A, this point of intersection, and this point of intersection is denoted by B. Okay. So this is the fluid element, triangular in shape, like a right angle triangle. This angle is right angle. Okay. And say the thickness in this direction is unity. In this direction is the Z direction, which is perpendicular to the board. Okay. That direction is only one. And suppose along the x-axis, the length of the fluid element is delta x. Delta x. You know, I have used delta. That means it is a very small quantity. Delta x. And along y, the length of the fluid element is delta y. Right? Right? And suppose in this direction, this is the direction of what? This is the direction of x. So in this direction, pressure is denoted by P suffix x. This is suffix, okay, P suffix x. And here, in the direction of y, pressure is denoted by P suffix y. Okay. Now, what is the length of AB? Length of AB, it is equal to root over of OA square plus OB square. Length AB. AB, this is equal to OA square plus OB square, okay, root over of this, which is equal to delta x square OA, actually OB square is equal to delta x square, and this is OA, which is delta y square. Okay. OB square is equal to delta x square and OA square is equal to delta y square. So that is the length of AB. Now, what is the force which is acting on OA, on the surface OA? Here, what is the area of OA? Area of OA. Area of OA is what? It is equal to delta y multiplied by unity. Because thickness is 1 in the direction of the perpendicular direction of the board. Okay. So this is delta y. Delta y into 1 is equal to delta y, and area on OB, this is equal to what? This is equal to delta x multiplied by 1, which is equal to delta x. Let me check whether everything is visible or not. Yes, everything is visible. There is no problem at all. You can see everything is clearly visible. So here, now we are talking about the fluid is at rest. Fluid is at rest. Okay. So that means it is not moving. There is no acceleration or retardation acting on the fluid element. Therefore, the resultant force on the fluid element must be zero. You know this thing. The resultant force on the fluid element must be zero. And since the resultant force is zero, therefore, force along x-axis and force along means net force along x-axis and net force along y-axis must be zero. So since resultant force F is equal to 0, therefore Fx should be 0, okay, and Fy also should be 0. You know this thing, okay. Here F is equal to what? Here F is equal to root over of Fx square plus Fy square. You know all these things from the knowledge of mechanics. You know all these things. F is equal to this much and F is 0. Since F is 0, therefore Fx and Fy are separately 0. Okay, so this is known to you. Now we have to calculate what is Fx. So here, therefore Fx is equal to how much? Fx, this is equal to what? Px multiplied by this area. This area is how much? Delta y. So Px multiplied by delta y. This is the force along x direction. Is there any other force in the direction of x? No, because this force is perpendicular to the x direction, so there will be no component of force in the x direction. But there will be one component of force. Here also on the surface AB. On the surface AB, there is also one force. Suppose in this direction, perpendicular to AB, the pressure is denoted by Pn. P suffix n, n for normal. Okay, this is the normal direction of AB. Okay, normal direction to AB is Pn. So this force is there. So this force must be resolved into two components, along x and along y. Now suppose along x means this. So what is this angle? Can you tell me what is this angle? Suppose this angle is theta, right? This angle is theta. Then what should be this angle? Force is like this. So component will be like this and this. Okay? This and this. So if you do this, so you will get here 90 degree minus theta. Right? If you do this, you will get here 90 degree minus theta. Then this is 90 degree minus theta, right? This angle is 90 degree minus theta. So this angle is theta. Right? Theta, 90 minus theta, 90 minus theta. So this is theta. This angle is here theta. So that means, and this angle is 90 degree minus theta. So what will be the component? Here the force will be Pn multiplied by this area. So Pn area is delta x square plus delta y square. Okay, this is the force. And direction will be what? Actually not this direction. Direction will be in this direction. Okay, direction will be in this direction. See, this is the force and direction should be like this. This and this. Okay, this is the direction of Pn, not these directions. Okay, so this is the force we are going to consider, right? So what is this angle? You tell me, what is this angle? Here this angle means this angle, right? This angle. So since this is theta, this is 90 minus theta. So here sine theta component will be coming. So sine theta with a negative sign. So this is Fx and this must be equal to 0. Okay. So sine theta is how much? Sine theta is equal to delta y divided by this. So from here we are writing Px into delta y minus Pn into root over of delta x square plus delta y square into sine theta, that is delta y divided by this delta x square plus delta y square. So from here we are getting what? Px is equal to Pn. This thing we have got here. Px is equal to Pn, right? This thing we have got. Now we are doing Fy is equal to 0. Here we have done Fx. Fx is equal to 0, from where we have got this. Fx is equal to 0, therefore Fx is equal to this much, which is equal to 0. So we have got this one. Now we are going to do Fy is equal to 0. This condition we are going to use here. So, sorry. So during doing this, here the force will be Py multiplied by dx. Py multiplied by, not dx, delta x, right? This is the force in the upward direction. Therefore, there will be one component of this force also, which is in the downward direction. This was sin theta component. So here will be simply cos theta component. So Pn delta x square plus delta y square multiplied by cos theta. One more force will be there, that is the weight of the fluid element itself. What is the weight of the fluid element? First you calculate the volume of the fluid element. Here this area is half into delta x into delta y, right? Half into delta x into delta y is the volume of the fluid element. Say rho is the density of the fluid element. Therefore this, this multiplied by 1 is the thickness. So this is the volume of the fluid element. Then multiplied by rho is the mass of the fluid element. Then multiplied by g is the acceleration due to gravity. G is the acceleration due to gravity. Therefore this becomes the weight of the fluid element, which is acting in the downward direction, vertical downward direction. So with a negative sign, I am going to write the same thing. Half rho delta x delta y multiplied by g, which is equal to 0. Right? Now, cos theta is how much? Cos theta is equal to delta x divided by this length. Okay. So, Py into delta x minus Pn into root over of delta x square plus delta y square into delta x divided by this hypotenuse delta x square plus delta y square minus half rho g delta x into delta y, which is equal to 0. Right? Now this hypotenuse and this hypotenuse, they are cancelled, and divide both sides by delta x. So after division you are getting what? Py minus Pn minus delta x, okay, sorry, then minus half rho g, minus half rho g into delta y. This thing we have got. Now we can see that Py is finite, Pn is finite, rho is finite, g is finite, while delta y is infinitesimally small quantity. So when the fluid element, size of the fluid element shrinks to 0, then in that case delta y also approaches 0. So ultimately this thing will be equal to 0. This term will be equal to 0. So from here also we are getting Py minus Py is equal to Pn. Okay. So here you can see we have got Px is equal to Pn. Here we have got Py is equal to Pn. That means ultimately we are getting what? We are getting Px is equal to Py is equal to Pn. Okay. So all the pressures are same when the size of the fluid element shrinks to 0. When the size of the fluid element shrinks to 0, that means the fluid element comes to the point O, that is the origin. Origin is the point. And here you can see this direction is fixed, Px, this is horizontal, Py, direction of this is vertical, perpendicular to x, but direction of n is not fixed. Okay, that direction of n depends upon the value of delta x and delta y. They are all approaching 0. Delta x and delta y are approaching 0, but actually they are not same. So theta may have any value. So that means at this point, when the size of the fluid element shrinks to 0, at this point all the pressures are same, and that was the Pascal's law. The pressure at a point in the fluid at rest is same in all directions. That was the Pascal's law. Okay, so you can see that this is the theoretical proof of Pascal's law. Okay, just due to this Pn, just due to the presence of this Pn, we can conclude that pressures in all directions are same if the fluid element is at rest. Okay, so this was the theoretical proof of Pascal's law. This was of course two-dimensional proof. In next video lecture you will see three-dimensional proof also. Okay. Okay, for thank you. Sorry. Thank you for watching this video.